and today we're going to put a couple of ideas together. So the first thing we need to talk about is this thing called periodic motion. So periodic motion is any motion which repeats itself over and over and over again. Maybe you're pacing in your house back and forth, that's periodic motion. Okay? Another name for periodic motion is sometimes a cycle or an oscillation. So you may have heard that. If you've worked with cars, you may know we have a 4-cycle engine. That means there's 4 steps in the motion and then it repeats itself over and over and over again. So a cycle, an oscillation, or periodic motion all mean the same thing. It's anytime motion repeats itself. So some examples that you might be familiar with are playground swings. When you hop on a swing, give yourself a shove, you go back and forth, over and over again. That's periodic motion. A guitar string exhibits periodic motion. When you pluck it, it vibrates back and forth. And how fast it vibrates tells you or leads to the pitch of the musical note, but it vibrates back and forth. A pendulum is an example of a periodic motion. It swings back and forth. Planets and moons are also examples of things that exhibit periodic motion. The moon goes around the Earth, and then it does it again, and then it does it again, over and over and over again. The planets go around the sun. Those are all periodic motion. You actually, in the old days when you went to school, followed a schedule that repeated over and over and over again. You went to first and then second and then third and then fourth, fifth, lunch, sixth and seventh. And the next day you did it over again. And so we say that is a periodic schedule. So the time that it takes to complete the cycle, we call the period of the cycle. So the period is the time it takes to complete a cycle. Some common examples of the period that you might know about. The moon goes around the Earth. How long does it take from when the moon is full until the moon is full again? Well, to complete a cycle from full moon to full moon is actually 28 days. So we say the period of the moon is 28 days. The Earth goes around the sun. How long does it take to complete a cycle all the way around the sun? Well, that's 365.24 days, which is what we call a year. A child is going back and forth on a swing. It might take 2.5 seconds from the time they reach their mom until the time that they swing forward and then back to their mom again. And so we say the period of the child on the swing is 2.5 seconds. Okay? We're going to use the variable capital T for the period. So capital T, think T for time. It's the period. We're not going to use P, we're going to use T because it's a time. It's a special time, the time for one oscillation or one cycle. So we've been studying the pendulum the last 2 days, and I think what you guys figured out from yesterday was that changing the mass didn't have any effect at all. When you change the mass, the period, the time it took to complete a cycle, always stayed the same. So the period of a pendulum doesn't depend on the mass. And you can actually check this out. When the park opens up, you can try it, or maybe if you have a swing in your backyard, you can try it. You can take the swing, hop on it, and find the period of your oscillation, and then put somebody else on it who has a different mass, like a kid or something, and time the oscillation again. You'll get the same result we got in the simulator yesterday, which is that the period does not depend on the mass. So anytime you're given the mass, you can ignore it. Little secret there. You don't need the mass. You can ignore it. We also found out the period does not depend on the size of the swing. Little swings or bigger swings all took about the same amount of time. With a bigger swing, you were going faster, but you had farther to go. With a small swing, you're moving slowly, but you don't have very far to go, and the time it took was the same. Today, what you figured out was the period seems to be related to the length. In fact, when we made the length 4 times longer, as you just did, the period only got 2 times bigger. So that hints at the relationship, which is that the period is related to the square root of the length. So it turns out that although some complicated math is involved, the result boils down to this. The period of a pendulum, So anytime you have a weight on a string, the period, the time it takes to swing back and forth, is equal to 2 times the square root of the length. Now, this only works on Earth, but that's good because we're mostly going to be doing our experiments on Earth right now. So take a second and pause the video and jot this down in your toolbox. So make a new toolbox in the back of your book for Unit 5 and jot this equation down. Make sure you note that T is the period, and that's measured in seconds, and L is the length, and that's got to be in meters, okay? If the length is in feet, you have to use a different equation, which we're not going to work with. So we're just going to make sure our length is in meters, okay? All right, so pause the video, write that down, and then hit play. All right, so let's use what we just wrote down to solve a problem. I've got a pendulum. It has a mass of 0.5 kilograms and a length of 2 meters. And I want to know how long does it take to swing back and forth. The period is how long it takes to swing back and forth. So the first thing I do is draw a little diagram. There's a pendulum. The mass is 0.5 kilograms, but as you may remember, the mass does not factor into the equation. So we're going to ignore it. We don't really need it. The length of this pendulum is 2 meters. It says the length is 2 meters, so we know L is 2 meters. And it says find the period, so we are looking for the period. So we're going to put a question mark down here, okay? So our plan is going to be this. We are going to solve our equation, which we just put in our toolbox. We're going to solve that to find T. So to do that, all you got to do is take 2 times the square root of the length, or 2 times the square root of 2, because the length was 2. So on your calculator, take the square root of 2, that's 1.414, and we're going to multiply it by 2. So take 2 times 1.414, and you get about 2.83. All right? So our equation tells us that the period of a pendulum is 2.83 seconds when the length is 2 meters. And we're going to solve some problems like this. I'm going to give you some different lengths, and you're going to calculate the period. All right? But before we do, it'd be really nice to know, does this actually work? I mean, all we've done is simulators and stuff. So let's try it. So if you want some bonus points, here's what you can do. You can make a pendulum that is about 2 meters long. Here's how you can do it. Tie a weight. Really, you can use anything. In my case, I used a mug from my kitchen cabinet. Tie it to a long string. Here I couldn't find any string, so I used a piece of curling ribbon from the Christmas box. It was purple, so nobody uses it for Christmas. And I measured 6.5 feet long from the cup all the way to the end of the string. And then I just held the string at the top of my door frame and then give this thing a little shove, and it's going to oscillate back and forth. And you might need a helper to do this. Maybe you need a helper to hold it there or something. Don't put a thumbtack in your door frame. That'll make your mom mad. Have somebody hold it. Swing it back and forth and measure how long it takes to go from one side over to the other and back. That is the period. And that should be 2.8 seconds or so. You should get almost the exact same answer. So if you can do this, take a picture and send it to me so I know you did it, and you can check and see if this actually works. Okay? And then we're going to solve some problems that just look like this. So you're going to go back to your online assignments now, and you're going to solve some problems using this equation. The period equals 2 times the length.